This video will continue discussing how to simplify radicals. So if we take a look at example 3, we notice that there is already a 2 in front of the radical. So that means when we get our final answer, we have to make sure to multiply our answer by 2. So method 1 utilizes our perfect squares. So remember, this list comes from 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. So we can easily make this list in like 10 seconds. Okay, so we have to look at this list and ask ourselves, do any of these numbers go into 72? If the answer is yes, then this radical we were given is not completely simplified. So I know that 9 goes into 72, but so does 36. So if I use 36 times 2, then I would be done in one step, because 2 can't simplify any further, and the square root of 36 is 6. However, if instead you were to choose 9 instead, so if we use square root of 9 times square root of 8, since 9 times 8 is 72, the square root of 9 is 3, but then the square root of 8 we can simplify further because 4 can go into 8. So we could split that into the square root of 4 times the square root of 2. And then 3 times 2 is 6. So we would still get 6 rad 2. We just had 2 steps. Now, method 2 has us take 72 and make a factor tree. So we could pick whatever 2 numbers we want. So if we want to use 9 times 8, and we keep going until we only have prime factors. Okay, now remember, if you want to check if your factor tree is correct, then all the numbers we circled here should multiply 3 times 3 times 2 times 2 times 2. And it should get you 72. So all these numbers multiply to get us 72. So then we think about the radical like a jail. To escape this radical jail, we need matching amount to the index. So if the index isn't, there's no number there, we know it's a 2. So we're looking for a group of 2. So these 2, but only 1 makes it out. And then we could do these 2. But only 1 makes it out, and then we'd have this one still left. So again, we would get the same thing. We'd have 3 times 2 is 6, and then the square root of 2. So same thing. So we'd get 6 radical 2. But remember that 2 was already there, so we're going to have 12 instead. Now, as for the variables, we have x to the 6. 1, 2, 3, 4, 5, 6. We want groups of 2. So since we have an even amount of group of 2, we have 3 groups. We're going to have x cubed, and then we're not going to have any x's left inside because there's no remainder left. So we can get the same answer if we just divide the index. So if we take the index, which is 2, and divide it into 6, 2 goes into 6 3 times, and the remainder is 0. So that's why there are 0 x's inside, and there would be 3 x cubed on the outside of the radical. Okay, so let's go ahead and check, try number 4. You should have instead square root of 24x squared for number 4. So method 1, we would take square root of 24, and we would use our perfect square list. So if this was a test, you would either on the side of your paper or ask for scrap paper and make this list, and then look at it so you don't have to make it for every problem. You would just use it for every problem. So we know that 4 goes into 24, so 4 times 6. Square root of 4 is 2, and then none of these numbers go into 6, so this is completely simplified. Now, if we want to use method 2, we can pick any 2 numbers we want. So instead of 4 times 6, for instance, I can pick 8 times 3. And then we keep going till there are all prime numbers at the end of the branches. And then we think of this like a jail, and we need two of the same numbers. So we have these two here, but only one makes it out. And then these two don't match. So we would have a 2 and a 3 left inside, which would get us 2 rad 6, which is the same thing we got here. Okay, then as for the variable, we would have 2 x's inside, and we wouldn't have any left. So we would have our final answer would be 2x and then square root 6. Okay, so if we take a look at number 5, we have the cube root of 8. So that is what times itself 3 times is 8. So 2. So we don't have to use method 1 or method 2 because it's a perfect cube. And then as far as the variables go, we can use division. 3 goes into 8 twice, so we would have x squared. And the remainder is 2, so we would have x squared inside the radical. And then 3 goes into 5. Oops, this should be a w here. So now I'm doing the x's. 3 goes into 5 once, with a remainder of 2, so we would have an x on the outside, an x squared in the inside. And then 3 can't go into 2, so we would have 2y still left in the inside. So our final answer is 2w squared x times w squared, or the square root of w squared x squared y squared. Okay. And then we want to always make sure that this was a cube root, so we can't forget the cube root. So we always want to do a double check there that we don't forget whatever the index is. That will never change. And we want to make sure when we write it, it doesn't look like cubed here, so we write it right there. Alright, let's try another example here. So we have the cube root of 54. So that means what times itself 3 times is 54? There is no perfect cube. It is not a perfect cube. So that means we would have to make a perfect cubes list. So we can't use this list that we were using for all the other problems because these are square roots, and this is a cube root. So we have to pay attention to the index. So when we look, if we're going to use method 1, we have to ask ourselves which of these numbers go into 54. So to make this list, you would do 3 times 3 times 3, or I'm sorry, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4 times 4, and that's how we would generate this list. And then we have to think of what goes into 54, and we can see that, 27 does. So we could rewrite this as the cube root of 27 times the cube root of 2. And the cube root of 27 is 3. Okay, now if we want to use method 2 instead, we would pick any two numbers we want. So we could pick 9 times 6, that multiplies to 54. And then we'd have 3 times 3 here. And 2 times 3. And then our index is, it's a cube root. So this time we're looking for a group of 3 of a kind. And so these 3 team up, but only one makes it out. And then we have the 2 left inside. So you could see we get the same answer using a different method. The variable part, we're going to do the same. 3 goes into 8 twice. So that's why we're going to have x squared here. And then there would be 2 left inside.